So I'm going to be talking about orchestration systems, another cool stuff. So this is the content of my talk. Also, if I talk really fast, I apologize. I'm used to watching a lot of these videos on like YouTube on like 1.5 speed. So I'm very used to like watching super fast talkers. Anyways, today my talk is going to cover like what is an agent, how do you orchestrate agent systems, the frameworks that you could use, and a little demo. So, what are agents? I feel like it's like a buzzword that everyone says, but people don't necessarily comprehend it. So if we think of agents in a very typical sense, we think of them as, like you have a travel agent, someone who does the bookings for you. So in the AI world, it's sort of similar. Like an AI agent helps you solve a task on your behalf. And an agent might have access to tools that might be able to search the web. It might have access to, it'll have some special set of instructions, like do not delete my database. Only do selects from tables. Don't delete tables. And so what powers the AI agents? They're powered like an out-of-box LLM. For example, GPT-5. You might have your own fine-tuned LLM. You might be running a really small large language model. And so that's been really popular. And when you're actually creating an agent, these are some of the factors that you want to consider. I know a lot of people here are interested in AI, and honestly, the secret to a successful agent is being very conscientious about what information you feed it. So obviously, prompt is the one thing. And I know a lot of us, including myself at work, struggle with prompt engineering it. Then it's the data that you feed it. As Nikolai mentioned, the documents that you get back need to be clean as well, because you can't just give it a bunch of text that doesn't make sense, that doesn't have the right context. Your chat history, you can't just give it like 100 or so messages of your chat history. It's just going to lose, like LLMs have a finite context window. They only have about like 100 to 200K context window. If you're Google, it's 1 million. But you want to be really selective about what information you give it. And this agent philosophies is respect to like how do you get the agent to think and how do you get the agent to do. So for reasoning, you could have an agent be like prompted, you're given this question, answer it. Then you have the philosophy of chain of thought, which is you are going to be given a mathematical question. Before you answer it, think about these are the steps that you should follow it. And then you have something which I think is really cool, and I didn't know was a thing until I was doing research, is a tree of thoughts. So if you know from your ML classes something like random forest, where each sort of decision is a node. It's something similar to that, where you guide the LLM by giving it a bunch of like possible scenarios and ask it to think, is this true? Is this false? If so, you do this. And I'll have a diagram, so the reasonings and the executions will become easier to explain as well. Then for execution, like you have fuzzy matching. Why might you do fuzzy matching? The reason for that is you might be like, if the user mentions a keyword pitch, write a pitch deck, and so forth. And then you have something called React agents. So I think React agents by far are one of the most popular type of agents, and this stands for reasoning and action. So you basically instruct the agent to be like, come up with the reason for why you're doing what you're doing, and then do it. And then see what the results of your action are. Reason again, is it done? No? Do it. And then we have something called review, which is reasoning without observation. So the idea is you tell the agent to think about what it's going to do, the steps, and just execute it, and it's done. So more about the agentic reasoning. So a lot of the examples that you're going to see online, when you go to like LangChain documents, Crew AI documents, and so forth, is going to be the first one. where the agent just receives an input and an output. The second is chain of thought. And this is something that a lot of like LLM, like OpenAI, Anthropic are doing, baking more and more into the models. They want their they want their models to more reason about why they're doing what they're doing. And then this is the last one, the tree of thought I was talking about, where it's sort of like you're sort of instructing the AI to go through like a decision flow. And this is the model for the React agent, where essentially it's getting an input and you first ask it to reason about what it's doing. Then it will do an action, either by usually by a tool. It will see the output of the tool and it will think, was this right? Was this wrong? And it keeps trying and trying again. And for Rewu, it's just doing the first two. It's just doing reasoning, action, and final answer. So you have these agents, you can build them. Cool. How do you actually get them together? And there's a lot of ways. So the reason why we talk about orchestration is you could build you could have a really awesome idea, but you will, as you start building with AI, or as you might notice that like agents really do well when you give it one particular focused task. And so if you want so let's take the example of travel booking. When you're trying to plan a vacation, you need to book your flights, book your hotels, find dates that you're free, and so forth. If you task one agent to do all of those things, you'll have to split your prompt to focus on those tasks. You'll have to make the tools, the agents will start making mistakes. However, with orchestration, what it allows you to do is break a task down. So each agent does one thing. One agent for flights, one agent for booking the hotels, one agent for finding out when you're actually free to go on vacation. And these are the different types of like orchestration. We have just a generic workflow, like it goes from A to B to C to D, and that's what you instruct it to do. We have multi-agent supervisors. We have this concept called Swarm, which was designed by OpenAI. And lastly, and I think this is so cool, but I haven't seen practical examples of it yet, decentralized agents. So the workflow, and this is a screenshot from a line graph example, and this example is doing text to SQL. So in their text to SQL example, the agent is first, you have an agent to list the tables, then get any schema information, then generate a query, check if the query is right, run the query, check if it's right, and so forth. Now, this is the one that most people use, and it's honestly like I think the supervisor model is probably like the one that's winning so far from the examples that I've seen. So the idea is you give it a question, like for a research assistant, like, hey, I want you to do some research for me. It's an example of the supervisor's like, the user has asked to do this. I'm going to see what are my available agents to do this task. Oh, I need to do a research. The research team has gotten some information. Now I actually need to write the documents. Swarm is a really interesting idea. So Swarm gets rid of the supervisor. And essentially what it allows the agents to do is each agent can essentially talk to one another. So you might have a question, so for example, with the travel example, you might be like, find me flights, book me a holiday to France, to the south of France. So it might go to the flight agent first. The flight agent will be like, okay, I've done my task, I'm gonna give it off to the hotel agent. Then I'm gonna give it off to the calendar agent, and so forth. And the benefit of something like this is if you get rid of the supervisor, you have to, like one thing that you always have to remind yourself is that it's a LLM's a non-determinate system. No matter how much you prompt it, no matter if you set the temperature to 0, sometimes it's just not going to follow the instructions that you give it. And so by trying to eliminate the supervisor, you're trying to give it a bit more, you're trying to reduce some of that variability. And Swarm could be one way to do that. And lastly, we have decentralized agents. So there's no supervisor, There's no like set network that it can talk to. It's not like Swarm where it's like you're passing it other agents as a tool call. The idea and the example for this is healthcare. So let's say I go to my doctor and my doctor's like, I want information on this patient. So it's gonna Dr. A's patient is Dr. A's agent is gonna reach out to Dr. B, Dr. C, Dr. C's agent may reach out to Dr. D's agent, and so forth. So the idea is that you sort of build this system where there's no one really in charge, and the agents have full autonomy to essentially talk to each other and so forth. And so now that you know the concepts of AI, what's an AI agent? How could I put it all together to get them to talk and do my tasks? Now it's time to talk about the different frameworks. So here are some of the popular frameworks, LangGraph and LangChain. So I can happily talk hours about LangGraph and LangChain, as that's something that that's probably one of the most popular ones, and that's what I use for my day-to-day at InterSystems. We have Crew AI. What I like about Crew AI from reading their documentations is that they seem to focus a lot on like some of the memory implementations. A lot of people notice like will have like a memory agent or will just pass the last 5 messages as context. So like Crew AI has some like when I remember reading their docs, they had some really, really good examples of how you can implement memory using the framework. AutoGen, I believe, is something that Microsoft offers. So I assume that like AutoGen works really, really well if you're going to deploy in Azure. Google ADK and A2A. So the Google ADK stands for Agent Development Kit, and A2A stands for Agent-to-Agent Protocol. What I really like about Google's ADK is that they do orchestration really well in the sense that they allow for each agent to be hosted on a different container. And so if you're thinking about scale, like that's like and you want each agent to be its own little application that can still talk to each other. A2A is a really good one. And Llama Index, that's like, again, one of the really popular ones. I think Llama Index is one of the ones in Frontier, especially if you're doing RAG applications. And then you obviously have these frameworks, and then to deploying them, a lot of the cloud providers will allow you to deploy them. Our host here, Amazon, they have this service called Bedrock. That's really fantastic. And Bedrock also offers like additional support that some of these systems might not, such as guardrails. And I believe Bedrock hosts their own models as well from OpenAI and Anthropic. So it gives greater inference speed. And lastly, I'm going to show you my demo. So I built the demo for so I'm going to pretend I'm someone who's applying to the InterSystems startup program. And what I'm going to apply with is I'm going to have a startup to get medical insights. So I want to show you for the same system, 2 different implementations. First is a single agent that has access to tool calls, and the second is a supervisor that has access to 3 different agents. So I'm going to go here. To make this more interesting, someone pitch me an idea that you would apply to InterSystems with. Just shout out if you have an idea. Sorry? Applying to universities? All right. So I'm gonna run this. So what the agent does is it will create, so if you go to the InterSystems website here, it asks for an elevator pitch, it asks for a pitch deck and a logo. So this agent is doing all that work. And I'm also gonna, so this is a single agent that is able to call tools. And I'm gonna ask the same question to a supervisor who is able to call different agents. So it's a bit slow, it used to be quicker, but that's fine. And so the idea here is that when you're thinking about building with AI systems, just because everyone is doing orchestration doesn't mean it's the right thing for you. And the same thing with like, and I just wanted to showcase here that even with the same problem, there's so many variety of ways to do it. And one of the best ways for you to go about trying to figure out what you want to do is honestly just experiment. And so over here we have a single agent that's generated like our pitch deck and our elevator pitch with the characters. If you look at a multi-agent, it just generated a text file with all of that, slightly more verbose. And yeah, that's my demo.